Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover matrix addition and scalar multiplication. So, if matrix A and B are both m by n matrices, so they're the same size, then their sum, a plus b, is defined by simply adding their corresponding entries. So what we'd say is matrix A, written in entry or component form, plus matrix B, written in component form or entry form, then their sum is just the addition of their corresponding entries. And this is for all 1 less than or equal to I less than or equal to m, and 1 less than or equal to j less than or equal to n. So this just says add their corresponding entries. So I have a couple examples here. So I have two matrices. In this case, what we can see is we have to check their size first. And if their size matches, then their sum can be defined. So what we know is these are rows by column, so this is a 2 by 3 matrix, and the same thing here, this is a 2 by 3 matrix. Since they're both 2 by 3 matrices, you just add their corresponding entries, so this is going to be equal to 2 plus 3, the next one is going to be equal to negative 1 plus 1, 5 plus 4, 0 plus 2, 3 plus 0, and then finally minus 4 plus 7. So then when we simplify this, we can say that a plus b is going to be equal to 5, 0, 9, 2, 3, 3. Now, same thing, we're going to try to add these matrices if they can be added. So what we know is this is a 3 by 3 matrix, and this is going to be, well, I have 3 rows, 2 columns, 3 by 2 matrix. And in order to add matrices, they must be of the same size because we have to add their corresponding entries, and there's nothing to add to this third column, so we'd say this is undefined. So for matrix multiplication, or scalar multiplication, let's try it again. So the way we've defined scalar multiplication is this way. So if A is an m by n matrix and then C is any real number scalar, then the product C times matrix A is an m by n matrix defined by this. So if I have C times matrix A in entry form, well, this is going to be equal to the matrix C times every single entry, for all 1 less than or equal to I less than or equal to m, and 1 less than or equal to j less than or equal to n. So really what this just says is if you're multiplying a matrix by a scalar, you just multiply each one of its entries by that scalar. So here's our example. So let's compute the scalar multiplication of C is equal to 4, and then A is equal to this 2 by 2 matrix. So what we have is we have essentially we have 4 times this matrix that says 3 minus 2, 0, and 5. And what we know is if I have C times a matrix, you just multiply all these entries times C, so I'm going to multiply all these entries by 4. So this is going to be equal to 4 times 3, 4 times minus 2, 4 times 0, and then 4 times 5. So then our resultant matrix is going to be equal to 12 minus 8, 0, and 20. Now with matrix or scalar multiplication, we can talk about, say, the negative of a matrix and then eventually get into subtracting matrices. So a quick example would be if A is equal to, let's say, 1, 5, 2, 7, then negative A is merely just negative 1 times matrix A. So what you can do is you can just multiply all these components times negative 1. So what that would mean is that negative A is just going to be equal to, minus 1, minus 5, minus 2, minus 7. And they don't all have to be positive. If this is a negative 7, well, if I multiply by negative 1, that just becomes positive 7. So it's just the opposite of all the entries. So what this will allow us to do is eventually define subtraction through the combination of addition and scalar multiplication. All right, so here's our example. If A is this 3 by 2 matrix, and then B also this 3 rows, 2 column matrix, then I can compute the subtraction of A and B. And the reason I can compute the subtraction is because essentially I can add the two matrices because they have the same size. And I also can find negative B if I find the opposite of this thing. So if I do A minus B is the same thing as A plus, negative 1 times B. So when I compute this can be equal to A, which is 5 minus 3, 0, 7, 9, minus 2. And this can be plus, well, the opposite of this matrix, so we know that this is negative 7, negative 2, 1, the opposite of 0 is still 0, negative 2, and 5. Minus 5. It is a personal choice on what you want to do. If you want to just go 5 minus 7, because what we know is we can compute the subtraction as long as you're careful, simply by subtracting the way we would in any algebra class. So I know 5 plus negative 7 is going to be negative 2. I could say 5 minus 7 is equal to negative 2. Negative 3 plus a negative 2 is going to be minus 5. So if I have negative 3 and I take away another 2, I'm going to get minus 5. So then 0 plus 1 is going to be equal to 1, or 0 minus a negative 1 is going to be equal to 1. So you can kind of see that you would compute the same thing, just as long as you're careful. So I tend to make students do it this way because sometimes they'll hit the negative twice and mess up these numbers. So just careful. So the last thing I'm going to do is I'm just going to do a combination of addition and scalar multiplication and see if we can compute something a little bit more messy. So our example is if A is equal to this 2 by 3 matrix and B is also a 2 by 3 matrix, and we have a couple real number scalars, what I want to do is I want to compute this linear combination of matrices. So CA plus DB. So I'm just going to write this out. So this is going to be 4 times matrix A, which is 5, negative 1, 3, 0, 7, 9. And then I'm going to add this to D, which is going to be minus 3 times matrix B, which is 0, 5, 4, negative 4, 3, 1. And what I'm going to do is I'm going to perform the, when we do this in any algebra or maybe any mathematics class, you do the multiplication before you do the addition because order of operation. So that's what I'm going to do. So this is going to be equal to 20 minus 4, 12, 0, 28, 36. And then I'm going to add this to negative 3. Really, this is the same thing as subtracting 3 times that matrix, but I'm just going to distribute the negative 3 like I did in the previous example. So this is going to be 0 minus 15 minus 12, 12 minus 9, and then minus 3. I like to perform it as addition as opposed to subtraction, so I don't have any minus negatives. I just can keep track of the signs a little easier. So now when we finally add this, 20 plus 0 is going to be equal to 20. Negative 4 plus negative 15 is negative 19. 12 plus a negative 12 is 0. 0 plus 12 is going to be 12. 28 plus a negative 9 is going to be equal to 19. And then 36 plus a negative 3 is going to be equal to 33. So I think you get the gist of how to add matrices and how to use scalar multiplication, and then the combination of the two. So if you like the content, please subscribe.